diazonium chlorides. Okay. Now you have to remember diazonium chloride. The structure of diazonium chloride. Just keep in your mind. It is N triple bond N with a positive on the central nitrogen. And remember, there is conjugation, alternate, single, and double bonds. And it is a salt, and therefore there is a counter ion minus. So these are the different reactions. Please by heart this. I will tell you by heart it. Please by heart this speech. Most probably you will get an exam, a reaction. What is that? A question from the university exam. Now, so you can see many of almost all the reactions which we have discussed yesterday with this compound removes a molecule of nitrogen from it, except the reduction. Almost all of them removes a molecule of nitrogen from the molecule. But here I'm going to give you a reaction which is very, very important in the sense that, in fact, the most important industry which utilizes diazotization reaction. The most important industry which utilizes diazotization reaction. What is the diazotization reaction? This is diazotization. HNO2. That is NaNO2 plus HCl. Giving you diazotized product. Diazonium salt. N2Cl. The most important industry is the one which is called a dye industry. And what they do is they do a coupling reaction. That is called a coupling reaction. Say, for example, this is treated with phenol. This is treated with phenol. Okay. Now, the product obtained is this one. Look at the product. The nitrogen is not removed. You get an azo dye. What is called? It's an azo dye. This is the product. This is called para-hydroxy azobenzene. Now this is having a very good color, and most of the compounds having the derivatives of these compounds, they are dyes, coloring agents. So this is the backbone of dye industry. So this is the backbone chemical reaction of dye industry. Dye industry. Okay. Now, so instead of this phenol, I can take many other compounds. I can take aniline. Oh, NH2, sorry, NH2. Again, the reaction is occurring here. Look at the mechanism of the reaction. I will write the mechanism. See, this is here N2Cl. This is your N2Cl. See this, positive. And then you have the phenol or aniline. See this. This is the most important thing. You have the lone pair of electrons here. You have the lone pair of electrons. NH2. Okay, see this. Look at the resonance structure. See the flow of electron. Look at the flow of electron. What are you getting? You are getting, follow the arrow, that is all. Nothing more than that. Follow this arrow. N, double bond, the lone pair has come here. N, again the double bond. See, this is the mechanism of the reaction. You are getting this double bond. N, H, H, with a positive charge. Oh, I can remove this one. NH2 with a positive charge. Now see what is the next step. Look here, you have a hydrogen here. This will get re-aromatized. Okay, so it is an aromatic substitution, electrophilic substitution. Okay, so what you get? You get your product this. So here you will get, you can have NH2 also, same thing, NH2. Suppose you have beta naphthol. Instead of phenol, you can have beta naphthol. It will get attached here at this position. Okay, here you will get double bond, N and benzene ring. All these are having very dark colors like orange, red. Clear? So these are compounds which are called dyes. A very good example for such a dye is methyl orange. You have heard the word methyl orange. Methyl, oh my God, methyl orange. Methyl orange is a dye which is made from, a reaction is very similar. You start with para-toluene, sodium salt of sulfanylic acid. This is sulfanylic acid. Na plus. This is what is called sulfanylic acid. SO3Na. Okay. This is reacted with NaNO2 and HCl. NaNO2 and HCl. NaNO2. That is HNO2. And you should not forget to put 0 degrees Celsius here. You will get ONA. SO3ONA. N2 plus. And Cl minus. So this is the diazotization reaction. Now this is coupled with NN dimethyl aniline. This is coupled with NN dimethyl aniline. What is NN dimethyl aniline? Instead of NH2, I have NCH3. Okay. What is the product of tin? The product of tin is SO3Na and N double bond NCH3 twice. Okay, so this is what is called a methyl orange. And it is used as an indicator in acid base indicator. Okay, in strong acid, strong base, and weak base, strong acid indicator. Okay, so that is methyl orange. So that completes this chapter. Now what we have to take is the next chapter is on biomolecules, which you are familiar. But before biomolecules, what I feel is I will take another chapter, or probably the last chapter, that is alkaloids. Then we'll come to biomolecules. Biomolecules is your topic, your subject, that is carbohydrates and all those things. Now we will take alkaloids. Alkaloids and terpenes. A big study is not demanding from you. I don't know. I don't know whether there is any change in the syllabus. I don't think it is there. It is still there in the syllabus. I don't exactly remember whether you have. Did anybody check it? You have the syllabus with you? Any one of you? Anyway, it's okay. I think it is still there. Okay. Now, let us look at alkaloids and terpenes. The origin of organic chemistry. Organic chemistry actually originated from the study of natural products. Study of natural products. What is natural product? Study of natural products. That is isolation of organic compounds from plants and animals. Plants and animals. Okay. So, so originally this is how it started. See, there are many, you must be knowing there are many plants in Ayurveda which has got a very good effect. What people have done is they have extracted this. Extracted means, the word extraction means making kashayam. You know the word kashayam, right? How do you make kashayam? You take all these plant material, dry plant material, dried, okay, and chopped into pieces. Chop it into pieces. Add about 10 times volume of water and keep on boiling it. The whole stuff will become black in color. The black solution, after boiling for about 3 4 hours, that is taken out and you are drinking. Next day, you are all again adding. I'm talking about the olden days. Nowadays, you are getting the kashayam and everything directly from the market. In olden days, what it does is what they bring that actual material, plant mixture of plant, and put them in big vats. Okay, uh, earthen pots, kalam. We call it as kalam, right? And then put it under. Now next day you add more water. Again, boil it for 3-4 hours. The volume become very small. Again, you take it. You repeat this for 5 or 6 days. 5 to 6 days. Okay. Now, so this now what is actually happening? Yes, your wood, your plant material become very soft. Plant material become very soft. Softness. Water enters inside. Water enter into the plant material. Water enter and extract out. The word extract means forcefully bring out whatever organic compounds are there. Whatever organic brings out organic compounds into solution. What is the solution here? Water. Okay, but the problem is it's way since the water is having least solubility for many organic compounds, you have you require a high temperature and large volume of water. High temperature and large volume of water because the solubility of these organic compounds in water is very small. So you are doing it for 5-6 days. The same process we can complete within 3 hours. If you change the solvent, you change the solvent into methanol or ethanol. Once you change the solvent to methanol or ethanol, you can do the same thing within 3 hours. Okay, because of the difference in solubility. Okay, now after this extract is taken out, say for example, methanol we are taking, we got an extract of this plant material in methanol. Methanol is having a boiling point of 63 degrees Celsius. So simply heat the mixture. Suppose this is the kashayam which you have got using methanol. What you have to do? You evaporate the methanol out. You will get a brown viscous mass. Viscous product, which will be containing n number of product compounds. N number. So many products will be there, chemicals will be there inside. Okay. So some of those chemicals are found to be basic in nature. Some of these chemicals, some of them were observed to be basic. Okay. And these basic chemicals were identified, and they were isolated, identified, and they had some common properties, and they were known as alkaloids. Now, which type of compounds are classified as alkaloids? Alkaloids are substances which have got and which are nitrogenous bases. Nitrogenous bases. Okay. Obtained from plants. Obtained from plants containing one or more. One or more. Nitrogen heterocyclic ring. Nitrogen heterocyclic ring. Nitrogen heterocyclic ring. So, and having marked physiological action. Having some physiological action. Physiological action. Meaning action on human body. That is what is meant by physiological action. So, what are the characteristics? They are nitrogenous bases. They're from plant, obtained from plant. They contain nitrogen heterocyclic rings and they have got physiological action. Okay. So they are nitrogen bases, plant origin, heterocyclic ring, and physiological action. This is what is alkaloid. So alkaloids are nitrogenous compounds obtained from plants containing nitrogen heterocycle and they have got some physiological action. What is the meaning of physiological action? It can have some effect on the human body. Either it's having a desirable effect or it can have an adverse effect or bad effect. Okay. The desirable effect, I will tell you, one of the earliest inventories of our heart drug for heart diseases was reserpine. It is an alkaloid. It is obtained from Nitya Kalyani or Shavanari. There is a particular uh, plant. You get a lot of fruits and flowers of that here. So that is the first very big, very interesting compound. Okay. Now, so this is alkaloid. Now we have a different classification of alkaloids. Very briefly, we'll mention the classification. A lot of alkaloids are there. Classification. Or we will take it tomorrow. Okay. Almost is time up. Yeah, time is good. So classification, we have to write a little. Right? So we will take up tomorrow. Tomorrow is Friday. And this Saturday also there will be class. Don't forget. Please attend. It will benefit you for the exam. Okay. Thank you.